Thanks so much for all the submissions that you did to the repo, all the presentations. Um, and yeah, we're following the agenda in the repo in the issue. The first person there is Red Too Happy, who was moved up from the previous meeting because he wasn't available a week ago. So the question is whether you are. I see that Red Too Happy is here. Yeah, are you ready?
Yeah, I'm here. Yeah.
Okay, awesome. So then we can start with that. Feel free to share your screen. Josh, do we have recording ready?
Okay.
Yep, we're
Can you see
recording.
my screen?
Okay, awesome. Yeah, if you have slides, please share your screen, and the stage is yours.
Okay. Can you see my screen?
No.
Well, how about this?
Um,
Does this
Nothing.
work?
Nothing. Yeah, I
Well,
don't see you sharing it. Oh, now? Now it works.
okay.
Awesome.
Well,
Yeah, yeah, yeah.
thanks everyone. My
Great.
project is securing gradient by fuzzing, and I'm happy. And my proposal is work along with the ball maps. And let's start with the motivation. And why we are choosing the gradient as a target? For the two main points is that the first, the gradient is a high performance consensus client with parallelism and efficiency. And it is very promising in the Ethereum main network, and it is prominent since it is used in production, like the Holy Sky test network. And there's many security concerns of the gradient is not complete so far. We need some thorough testing and fuzzing techniques to secure the gradient and implement, and we need to find some implementation flows between the gradient and the lighthouse. This is not fully researched since we currently only has a single audit performed by artists, and that audit is performed several months ago, and we can see that there's no automated CI testing or fuzzing method for the newly updated code, and since the CI infrastructure is lacked, the newly updated code is not being scanned and is not secured as well. So the main challenge is that there's many complexity of understanding the differences between the gradient and the lighthouse, due to the lack of the documentation. And the environment configuration is also hard for us since setting up the live debuggable environment for the consensus layer is challenging. And we need to choose some we need to choose some semantic aware fuzzing techniques. Also, we need some well-designed sanitizers and concurrency detection tools. Is also to be considered in the Rust environment. Finally, some bugs may be deep hidden in the complex model, and we need to identify the root cause. And we do not have many experience in the consensus issues, and we will require more knowledge to debug. So our project goals is that we will demonstrate a detailed comparative report between the gradient and the lighthouse, and we also will perform the enhanced fuzzing techniques and recommendation for the gradient projects. And we will integrate our fuzzing into the modern CI pipelines or like the OSS files. And we will explore and identify the most promising testing techniques among the property-based testing and sanitizers and the currency testing tools. Our solution includes comparative analysis and also the property-based testing infra. And we will apply the state-of-the-art fuzzing tools, which is most compatible to the gradient. And we also will develop many small individual fuzzers for the independent models implemented by the gradient. And we know that many models are shared between the gradient and the lighthouse. We will finally integrate the fuzzer to the upstream fuzzing framework like the OSS fuzz, which is fuzzed every day by the Google. And that's my project proposal. Thanks, everyone.
Awesome. Thank you so much. So you work on this with Boma, right?
Yeah.
Yeah. Haven't heard from her, so just checking. Yeah, I think it's great. I think it's interesting. Just to check whether you've been following Marius and his fuzzing work, which is mostly Golang. But like there's a lot of existing fuzzing infrastructure that you can take inspiration from, and the main cross-client testing being done is using Hive and Kurtosis. So it's like just wanting to say that it's there. There's cross-client tests, um, and it's on a different level. Like the fuzzing is mostly for something else. So just checking whether you looked into these other or existing efforts.
Yeah. And we work closely with the maintainers of the Gradient.
Yeah, like I would. Yeah, that's great. I would recommend just checking with Marius, for example, who's did like extensive amount of fuzzing. So he might have some good insight there as well. Just
Okay,
just to,
thanks for your suggestion.
yeah, awesome. Yeah, thank you so much.
Yeah,
Any
thank
other
you.
comments, questions? Okay. Yeah, thanks a lot. Um, Next up is Hamid, first one who commented under the issue. Yeah.
Hey, do you hear me?
Yeah, all good.
Great. Let me just share my screen.
Yeah, looks great.
See
Go
my
ahead.
screen?
Yep.
Great. Hey everyone, I'm happy here finally presenting my project. My project title is Inclusion List with Plausible Deniability. What that means and why it's important and why I choose this one. Just before deep diving on the project itself, I want to talk about the flow I just decided this project. And let's start. In the starting of the program, I just have a two topic in my mind, privacy and censorship resistancy. And I just checking the different idea, different EIP to choosing one of them to implementing. And after few iteration, I just figuring out something important. Censorship resistance in base layer is a prerequisite for most of the privacy approach. We can't have a censorship resistance in our base layer and after that we just develop the privacy approach. The just validator or the purposer could just simply censor all of the privacy related transaction, and because of that this is a really important prerequisite, and because of that I just dropped working on the privacy and I just focus most of my attention to the censorship resistance idea. And before deep diving on the solution, let's check about the current status of the censorship resistance on the Ethereum base layer. This diagram is from the censorshipresistant.pix website, and its website just monitor most of the validator and the relayer they are using, and the builder they just posted their execution payload in that relayer. And the statistics says near to 60% of the builders just censoring some certain type of transaction. This site says the OFAC related, OFAC non-compliance transactions. And after that, we can see this could affect most of the network. This 10%, it's not correct. Why it's not correct? Because most of the validator, if they want to be rational and earn more money and doesn't involve to doing MEV searching and block building by themselves, it's really logical decision to using one of these relayer. And when they are using this relayer, they connected to 60% censoring builders, and that's affect the whole networks, and that make it really bad. And let's see why the censoring could happen in here. Before the proposer builder, I'm not going to talk about the PBS because I'm sure most of you know about the PBS. And let's just check this. Before the proposer builder separation, the miner and validator, they are responsible for selecting the transaction from mempool, and after that putting that transaction in the block body and executing those transactions. And let's say if we have a lot of validator, we have a lot of solo staker in our network, the censorship resistancy happens by itself automatically. But after the PBS, most of our validator and proposer have a really big incentive to using these builders. And these builders are kind of dangerous for our censorship resistancy power in the Ethereum. So what is the solution, and what type of the things we can do to solve this problem? The things in here is that we can have a two approach. One of them is the active actions to fighting back for the censorship resistancy, and the second one is a passive approach. What is a passive approach? The bunch of idea that helping to the Ethereum to onboarding a lot of new staker, a lot of new solo staker to the networks. If this onboarding happen, the censorship resistance status also get better. But what is the, or we can have a kind of active solution? Yes, just like the problem statement in here. Our problem statement is that the proposer, our proposer, just lose their power and delegate that power to the block builder for selecting the transaction, and they doesn't have any power on this transaction selection. Can we have a kind of solution to take part of this power back? And we can say yes, the inclusion list is kind of idea doing that. And how they are working, the inclusion list, in one sentence we can define the inclusion list like this: one approach that allowing one verifier or set of verifier enforcing the inclusion of one transaction or some certain of the transaction, some certain censored transaction to the builders. And this idea get started from 2 years ago, and it's going on, and it's really space, a lot of open question in the design side. For example, let me just elaborate some of this design space. Should the inclusion list get applied on the current slot or the next slot? Forward, they call it the forward inclusion list. Or what's gonna happen what happen if the next slot proposer doesn't propose any block? Are these inclusion lists get accumulated for the next slot or not? These are the type of the questions, open question in the inclusion list. And as I mentioned, there is a really huge design space in here. And as you can see, from 2 years ago till now, we have more than 10 design for the inclusion list. So which one I want to implement it? Before doing that, I want to tell something. In the middle of the June, I just start talking and having discussion with one of the original EIP author of the inclusion list, and I just figured out the inclusion lists are not gonna happen for the Petra because the inclusion lists really have a lot of conflict and a lot of same related architectural question to the EPBS. And we need first that EPBS get implemented on the network, and after that designing the inclusion list. And that was inspired me. Why not I'm just choosing really experimental idea on the inclusion list instead of choosing the fully ready to implementation idea for the inclusion list. And because of that, and also having the privacy and anonymity in my mind, I just find two ideas that got my attention. One bit per attester inclusion list, and another them is anonymous inclusion list. What are the shared things these two ideas we have? But these two ideas are caring about the anonymity or plausible deniability capability for the validators. What are these and why they are important? Let's say in future, we don't have any kind of anonymity or plausible deniability for our validators, and this validator or proposer is a normal legal entity, and everybody knows that legal entity, and everybody knows their addresses, and everything is public. And someday this legal entity and proposer just put some transaction in the inclusion list, and they're gonna have a really big problem with the other legal and restriction they're gonna have with their legal entity. And this is a really big important problem that can prevent from the adoption of the inclusion list. And because of that, I really like these two ideas, because these are adding some layer of the privacy for the validators and adding their and giving them some plausible deniability capability. And if someday they have some legal problem, they can just plausible denial that problem. They said, it wasn't me, I just sent a wrong bit. That my bit doesn't belong to this transaction you mentioned, because in the 1 bit per attester inclusion list, every attester is only responsible for 1 bit of transaction. And one transaction could have a 200 bits, more 2000 bits, or more than that. And let's say nobody can just accusing this proposer for sending that transaction to the inclusion list. And because of that, I really like this idea. And another idea was that anonymous inclusion list. This idea using the ring signature to adding to capabling the private committee for creating the inclusion list. And that was a really interesting idea, but I just dropped it because it needs some sort of the central component for performing that. And because of that, I doesn't like it, and because that, I just dropped this idea and choose working on the 1 bit per attester inclusion list. And and choosing work on the 1 bit per attester inclusion list. I think I'm gonna have the 2 minutes. That's right.
Yeah, go ahead. Just
Oh,
don't take too long. Yeah.
okay. So I'm gonna drop the rest of the thing I want to mention in here and moving forward. And what's gonna happen in the implementation side? I'm gonna implement this idea that Vitalik just published in the middle of the June for the 1 bit per attestation. It's work based on the error correction code and in parentheses binary Reed-Solomon codes. First of all, I'm gonna implement the binary Reed-Solomon for attesting for single bit of the sensor transaction, updating the fork choice, updating the to add a new API to our execution client to returning some sort of the sensor transaction based on the predefined logic and create the test for new specification. As I mentioned, the 1 bit per attester is just the idea. It's not a fully ready specification for implementation. And because of that, I need firstly to define the specification for myself, because 1 bit per attester is just have an idea for one phase of the protocol, construction of the inclusion, and it doesn't talk about the rest of the protocol we need. And I'm gonna define the rest of the protocol by myself. I'm gonna write the test for that, and I'm gonna use the rando for creating the new committee per slot for creating the inclusion list, and rest of the things I need to implement. For example, I need to create the detecting the ticks invalidation via the native account abstraction in the execution layer, because let's say one validator just put the transaction in the inclusion list, and after that, that transaction get invalidated via the native account abstraction that we are gonna have in future. And these proposals are gonna get failed. Because of that, we need to kind of design a solution to preventing that. Also, I need to doing the attestation aggregation over the P2P layer. This is one of my challenge, because there are gonna be really huge amount of the attestation object that I need to aggregate them per slot, and this is one of the challenge I should solve. And that's it. Please just reach out to me if you are interested to the idea, and these are my contacts. And please just check out my project proposal if you want to know more about the project description and roadmap and specification. And also, I like to join the FOCL working groups that the Amin and Lena on it, because both of them are working on the inclusion list, and I also gonna work on some variant of the inclusion list, and I really like to have a communicate with their and having some feedback and giving some feedback to them. And that's it. That was my presentation. Any question, any comments? Sure. Mm, Dan, please just open up your mic and talk.
Yeah, any questions?
Okay.
Yeah.
So the project is mostly on the experimentation part. Did I understand correctly? You're just going to to work on the specification during EPF project, or you will also have an implementation or a POC, or
No, I'm not gonna just working on the specification. My specification should get ready by the middle of the August, and after that, I'm gonna work on the POC with using the Lighthouse and also the rest as an execution client.
okay? Thank you. It's intersecting EL with EPBS is going to be a
Yeah,
not. Yeah. Okay. Good luck.
but I'm not gonna implement the EPBS part because I'm just doing this for experimenting and having checking the network operation and checking that 1 bit per attestor could work or not. Any comment? Any question? Thanks, Katya.
Yeah, anyone? Yeah, thanks a lot, Hamid. I think it's really
You're
great.
welcome.
I really
Thank
appreciate
you.
your work. Previously, you worked on the private transactions EAP, and it's great that you continue on with. Uh, I really like your motivation there. Like, we need the censorship resistance to enable any kind of privacy or really anything. So, and that more privacy, more plausible deniability for validators. I think it's really cool. Yeah, wish you luck,
Yeah.
man.
Thank you
Awesome.
for feedback.
Awesome. Yeah. If there are no more questions or comments or anything, let's move further. With Kira. Yeah.
Hey, yeah, let me share my screen.
Go ahead.
Can you guys see my screen?
Yep. Looking good.
Okay. Right. All
Yeah.
right.
Great.
Yeah. So like, there's one more teammate of mine, like Aman is gonna start.
Yeah. So hi everyone, I am Mohammad Aman, a permissionless candidate. So our project is basically the implementation of EIP 7732, which is enshrined proposer builder separation. Our current scope is for Prism. Once we have done implementing it on Prism, we will possibly go to a Nimbus client. So currently our team consists of Caleb, Kira, me, and Jihun, and mentors who are mentoring us is Potus, Terence, and Tersek. So yeah, current motivation. Before going on to the motivation, let's get some context on EPBS. So currently, the proposer builder separation, it is handled out of the protocol by third-party software such as MapBoost, as mentioned by Hamid. So that is reliability. We have to rely on the intermediary software for broadcasting our blocks. As a proposer and as a builder, it is much of a pain, as this is a critical issue for censorship, as well as there is a risk that is associated with it, that is the centralized concern, that is 94% of the blocks are handled by 5 relays as per last 14 days data. So here the actual problem is that the proposer want to sell his right to build a payload to a builder, and a builder also wants to buy the right to build the payload, but they both need to trust a single intermediary, that is a relayer in our case. So we need to remove this trust barrier and make a trustless intermediary, which is a inbuilt protocol, something like EPBS. And this issue is not small, because due to this the whole concept of decentralization is getting denied. So yeah, this is what we are going to solve through EPBS, and the project specification and description Kira is gonna discuss. And yeah, over to you,
All
Kira.
right. Yeah. So to describe more on the solution and problem, the project is fundamentally about solving a trust issue, and it's not about transaction ordering or MEV. So like MEV considerations such as MEV stealing or and foreclosure attacks are not the core issue here. So currently, most of the beacon block proposers in Ethereum rely on third-party builders to construct the execution payload for the blocks. They request hash key root from the builder and submit their signed blinded beacon block to a trusted relay, which would then eventually replace the hash key root with the full execution payload before broadcasting it to the network. So yeah, as you can see, like this process requires a trusted intermediary, in this case relays. So solution for this is, um, validators have a short window in Ethereum, like 4 seconds of window to validate both consensus and execution state transitions, check data blob availability, and evaluate the new head of blockchain. By separating these validation tasks, validators only need to perform the consensus state transition immediately, and like this way, like we can defer execution and data ability validation to later. uh, this will like result in faster network propagation, reduce that were caused by block transactions, and also like avoid validators missing their attestations. uh, and the main thing, it would eliminate the trusted intermediaries. So on the spec side, uh, the implementation would follow the implementation would follow the spec mentioned in EIP 7732. The spec introduces a new stake participant called builder. On like it also introduces honest validator duties called payload timeliness attestations, and the concept of payload boost, reveal boost, withdraw boost. I'm not going into details of all of this, but I'm just going through that. It will also introduce a payload timeliness committee for checking the timeliness of the builder's execution period. So yeah, this is what an EPVS slot would look like in our solution. So the slot in the Ethereum protocol would be divided into 4 intervals. As you can see, like in the first interval, like from 0 to 3 seconds, honest validators would gather signed bids from builders and then would commit to one of the bids of their selection, and they would submit a signed beacon block with this bid. So at this point, they don't know what the payload for the builder is. They only know what the value of the bid is, and the signed and they have like signed bid from the builder. For the second slot from 3 to 6 seconds, honest validators would submit their attestations. This is similar to what happens right now. For the third interval, aggregators would aggregate this attestations, and the builder would broadcast either the full payload, or if they see a weak block from the proposer that has like low weight, builder can also choose to like send a message that they are withholding their payload through signed execution payload envelope. And finally, for the fourth interval, a new PTC committee would be formed. Some of the validators, in this case, like 512 validators, would be selected from the set of present validators, and like they would attach to the presence and timeliness of this builder's payload. So more on the roadmap. For the month of July, we are implementing the helper functions mentioned in the spec. This will also help us to get familiar with the Prism code base and how the flow works. For the month of August, we are planning to implement the packages that are mentioned in the spec and have a running version of like have a running initial version of POC. In the month of September, we will do some functional testing, and like there's like 2 weeks of buffer if there's like any delays and stuff. For the month of October, once we have working POC, like we would implement networking modules that will handle block auctions, P2P bids, gossip protocol, etc. And for the month of November, like we would finalize on some touches and the presentation at DevCon. Yeah, thank you. That's it. Like any questions?
Very well, thank you guys. Um, Yeah, do you have any questions, anyone? Yeah, I'm wondering like, yeah, Scooby, is there a question or?
It's just by mistake. Sorry for that.
Ah, yeah, sure. Yeah, I was just wondering like, what is the idea behind like switching to Nimbus? Like, how did you decide focusing on Prism and have Nimbus as a fallback? Like, why even have a fallback and then why Nimbus? Because like Nim is kind of weird language that you have to get into, and I understand you work with Potus from Prism, so yeah.
So the idea is like once we implement in Prism, like we need like more support from other client teams as well to like have this in production or like on mainnet. So that's why like we are also trying to get as many teams to implement this.
Okay, okay, makes sense. Yeah. Yeah. Cool. Cool. Thank you so much again. It's great. Yeah.
Uh, yeah.
Yeah. Look forward to see more of you guys. Um, and if there are no more questions or comments or anything, we have Rupam next.
Yeah, let me just share my.
So
So is it visible?
yep, looks great. Yeah. Yeah. I just wanted to say one quick thing. Like, so yeah, we are a bit time limited. Don't take too much time on the motivation or like explaining the concepts. Like, what is PBS? What is a light client? Like, mention some basics, but assume that people who are listening to this presentation are aware of all the like fundamentals and research areas of the
Uh,
protocol. So,
yeah,
you know,
yeah,
just
yeah, sure, sure.
focus more on your work. Yeah. Awesome. Go ahead.
Yeah, yeah. So hi everyone, Rupam here, and I'm working on this project like client support in Prism. I got two other fellows working with me, like Bastian and Rahul, with our mentor, Mr. Radek. So yeah, moving forward, currently the beacon network looks something like this. There are some beacon full nodes. Some of them are validators and some of them are not, and like they and they have a block, and the block has block header, transactions, attestations, and other payload. And the work of a full node is to like verify this header, verify transactions and state changes, and check attestations, check other payload and other proof of stake mechanics checks. So all of this is a computation heavy process, especially the state changes. It takes a lot of computation power in terms of both memory and like in terms of both memory and storage. And you need a 2 TB SSD and a decent amount of RAM to run a full node. So what Lightline fixes is that it removes these hardware necessities for running a node. So what does a light client get? That a beacon a light node will just connect to a full node, and then it will get a block like this. It will have the block header, a sync committee signature field, a sync committee bit field, and next sync committee. So what the light client does is it verifies the sync committee signature and the sync committee bit field, and based on the verification it accepts or rejects the block header. Now one thing to notice is that there is no state related computations here. So uh, obviously the computation power is much less than running a full node. And if any state related information is required, you can just query it from the full node that the light client is connected to. And you can just check it if it's correct or not by just having, because you just have the block header, you can just check against it. So right now, like client support is present only in Lodestar and Nimbus, and we plan to add it to Prism too. The roadmap would be something like to read and understand like lines and then compare to CL specs. And there are, and we have gone a bit outside the project details. Like the project details only specifies full node, but we have decided to full node for Altair, and we have decided to implement it for Capella and DNF too. So we will be implementing some new features from Capella and DNF too. So that's what for the roadmap. There is a more detailed roadmap posted on GitHub. The link is in my project proposal. You can get it from my development updates. And yeah, that's it for the roadmap. And last but not the least, I'd like to thank the fellows involved, Rahul and Bastin, and like our mentor, Mr. Radek, for the help. So yeah, that's it. Any questions?
Awesome. Thank you so much. Guys, any questions, or Rahul, Bastin, any comments, or anyone? Yeah, it was great. I really appreciated like pretty like succinct presentation, like short and sweet, well said. All the details of the light clients, and I think it's important project because the Altair has been around for like what is it, 2024, like 3 years, and
Yeah, yeah.
these clients still like don't support the light client protocol. So yeah, it's great.
Yeah.
Um,
By the way, the detailed roadmap I was speaking about, I will just show it. It's this like, it's a very detailed one, like a very technical one. If you want, you can like just check this out. It is like linked in my project proposal. And the first thing, the implement is better update. I am kind of working on that right now. And also, like this is kind of out of the project scope because it implements the helper function from the sync protocol markdown file and not the full node file, which, and only the full node file has been mentioned in the project. So yeah, that's
okay, awesome. Yeah, thanks for elaborating on that. And if there are no more questions or comments or anything, Ovanikin is, oh, sorry if I butchered the name. Um, yeah, Ovanikin, yeah, is the
Yes.
next in the list. Yeah. Yeah, feel free to share your screen. Go ahead.
Can you see my screen?
Now I can. Yeah, it's all good. Go ahead.
Can you see my screen?
Yeah, I can see, but I can hear you a bit worse. Maybe the bandwidth is limited. Yeah. Yeah, I can see the whole screen now. Go ahead.
Uh, okay. Hello, everyone. I'm Michelle Dua, known Owaniki on Discord online. And my project for EPF5 is that specific cryptography in Grandin's Rust KZG. And my motivation for this project stems from, should I say, all the interesting talks about Ethereum scalability, sharding, gas, cryptography, all this stuff, and on that specifically, we all know how DAS as a technique, allows Node to verify the availability of block data without having to download the entire block. I mean, and all of this sort of helps to lower the resources there and increase throughput, which is believed to be very crucial for scaling Ethereum, right? As it reduces the burden on individual nodes and the kind of the amount of data they get to carry and store. But however, there's no that specific cryptography currently implemented in Grandine, which I like to pick up. And I think it also gives me an opportunity to, and hopefully others, learn about DAS, have a better understanding of it and its cryptography, its maths, because it can be quite it can be quite a lot. With my project description, the project itself involves implementing some critical cryptographic functions that are outlined in the consensus specs, in the specs, and you know also implementing this in Vox KZG library, you know, the library itself will be able to do some interesting things, polynomial commitments, which I'll talk about briefly in the next slide. And definitely, we hope that it is, lightweight, efficient, user friendly, all this stuff. It's And more importantly, Grandin can use it, and hopefully other Rust implementation of the consensus client can also make use of the library. The specs, outlined in this consensus specs, the EIP 7594 polynomial commitment, they are majorly divided into these three functions: uh, compute cells and KZG proofs, which helps compute all the cell proofs for an extended block. There's also it verifying the cell KZG proof batch. This, helps verify that the cell belong to their corresponding commitments. There's a lot of commitment going on, and recover cells and KZG proofs, which I think the major idea is that, like, if given at least maybe half of the cells, say 50% of the cells for a blob, uh, then you can recover all the cells and its corresponding proofs, right? Um, so on the roadmap, first is just deep diving into the consensus specs itself, and its its commitment, the math behind it, and a lot of the should I say resources or documentation on KZG and its the top the mathematical concepts behind it, and making good use of it. There's also referencing existing DAS implementations, some of which I think CKZG has some minimal implementations. We are taking a lot of inspiration from that, and then hopefully start doing these implementations in those KZG, some of which have started, very bare bones currently. Then afterwards, we can, develop and implement some testing plan. So at least test out everything and make sure it works, and ensure some compatibility with Grandin and other Rust implementations of the consensus clients. So my possible challenges, definitely knowledge gap, some of which I'm trying to close currently. And these knowledge gaps regarding maths, cryptography, implementation as well, also Rust, a lot of things that are involved. And also limited resources and docs. There's no, I think it was someone made mention of it that Grandin has, is because they are new, just open source. There's not a lot of resources out there on Grandin, and but I think Solius has been of great help, and definitely I'll just rely on the consensus specs, outlined in EIP as my docs and my resources, and definitely client testing and debugging, standard challenge. So the goal for the project would be to have a fully working and tested implementation of DAS cryptography in Rust KZG library, make sure that it's working, and also be able to provide some comprehensive documentation for anyone who would like to use them, and have some benchmarks or showcasing these enhancements. So my collaborators, myself, Owaniki, and working with Village Farmer, and we have Solius as a mentor. And I think that's the end of my presentation. Thank you very much, everyone. Any questions?
Yeah, awesome. Any comments, questions? Yeah, I think it's a great project. Yeah, Grandine being a young client definitely needs help. So it's awesome you contribute there. And I'm wondering, maybe like if you looked into Lighthouse in a way, like, is their work reusable in grinding? Like, can you make your job easy by reusing the libraries or so?
Uh, I very early on, I spoke with Daplion on trying to do this, but I think I'm going to. So it gave me some things to check out, tracking all of these issues in Lighthouse. So I think I'm going to look deeply into that as well and just ask him questions if I have any. But yeah, I think I should look into that deeply.
Yeah, yeah, that's great. Yeah, I mean, makes it much more reasonable project when you have something you can rely on and somebody to ask. Yeah, it's great. Awesome.
Thank you
Okay.
very much.
Yeah, very well. Thanks a lot again. And next on the list, Adit Gupta.
Yeah, I will be sharing my.
Yeah, go ahead.
So is the screen visible?
Yeah, yeah, all is good.
Yeah. Okay. So I will be so my Ethereum protocol fellowship project will be on the stateless execution with witness, which I will be implementing in Red. So yeah, so yeah, so about the project description. This project is currently implemented in Git and was made live in the recent release of the Git. So the concept of this project is like basically focusing on the client diversity before worker trees. So currently, client diversity is very much important in the Ethereum. To explore the problem to more depth, I will just explain some few concepts. For example, to the client diversity is important because of the aggressive slicing present in the Ethereum network. So if slashing is done to a large extent, then majority of validators will face loss of repercussion, and this will lead to a major reorg in the chain. So this is not favorable, and it is totally not accepted. So to enhance this, to uh, prevent this, we follow the concept of client diversity. So in the consensus layer, a proposed solution was to enhance so that the every client should have a say of less than 50%. But this cannot be implemented on the execution layer side. Execution layer side, we have few solutions such as using a minority client, but using a minority client have its own consequences of new computer architectures and testing and metric locations and all. Another approach would be to run multiple clients at the same time, but this is not favorable for solo validators, but it might be favorable for large validators. So we introduce a new concept called as we produce in one client, but we verify the same payload using multiple different clients. To understand this feature to more extent, let's just get the overview. So currently the block transaction is done in Ethereum such that payload is received by an execution client, and it just execute all the data in the payload, and just it just checks whether it is correct against the block header data. But instead of just accepting this result, we can do a cross validation with other clients as well. For example, we can just propagate a witness along. So actually, the problem with this will be that there will be a problem of state maintenance. So even if we do a cross validation with other clients have to maintain a state and repeatedly update their state and use their own local chain. This is not favorable, and we are back to our own problem again. So we introduce a concept of stateless execution with witness. So what is witness? So instead of using a state, their local state, the client will be entirely relying on a witness. Witness will contain all the data needed to execute the transaction in the payload. So yeah, this is really the concept of execution with witness. Yeah. So yeah. So what will be the things which will be which are required to be implemented in this project? So first of all, we will be required to define a witness bundle. So content of the witness bundle will be all the account nodes and the storage nodes which were accessed by the transactions in the block. all the bytecodes of the contract which was accessed, then all the accessed block hashes, and then we will also have to see that the reading and the writing of the witness are done at the same time. So this might affect the witness construction due to the different structure of the tri nodes. Uh, yeah, and there should be a solely different mode so that the client are not dependent on the local state, but they will execute the block entirely on the data provided by the witness. So these few things need to be implemented so that this feature is currently so that we can make this feature live in the execution client. There are some caveats in this project. First of all, we will not be using Merkle tree for providing this witness proof. We will be modifying the existing Merkle Patricia tree for this only. So due to this, the witness size will be large so that the latency issues will be introduced in the witness propagation because size of the payload will be increased. There was some research which showed that currently we are using RLP encoding for witness proof encoding. But if we shift to SSDs, then there might be some improvement in the latency, but still it not be not that much good so that the users will be using because already there is very few time for the slot production. So ultimately, this thing will be corrected by Merkle Patricia tree only by shifting the proof to VPT proofs. So yeah, this will be the project caveats. So what the basic plan is that I'm thinking of implementing this project and testing it and creating a full benchmark project within a month or 1.5 month. And if this project gets completed according to this specified timeline, I will shift to a new project called as the Red Circle POC. I am currently in talks with the Red team. So, so this Red Circle POC will require me to completely scrap my whatever thing I did for this month and then shift to Circle trees. So currently, few clients such as Nethermind, Get, Ethereum JS already have implemented a fully fledged Merkle POC, but Red has not. So for this project, I will be using the Rust Merkle. The Ethereum JS team has already used the Rust Merkle some bindings in the project, so that might prove to be a good reference. So this will be a very long project, and I will be taking this up once I have completed the execution with Witness project. And the ultimate goal of this project will be if the RET is able to join the latest iteration of the constant devlet, which is the devlet for the Merkle trace. So this will be the expected timeline. The first month till the end of August, I will be completely focusing on implementing this execution with witness feature in the RET, benchmarking it and testing it completely. Parallelly, I am deep diving into Merkle trees. I am reading all the articles and the associated lectures and everything related to the cryptography. I have fronted my contribution to the Rust Merkle. Basically, most of the bindings are done in the Rust Merkle, but some optimizations can be performed, such as the tree access of leaf nodes is not optimized. We can use recursion there to optimize this performance. So this type of things I am contributing to enhance my knowledge. Once this project is completed, I will be starting with my proposal on the Red Merkle POC. Red Merkle POC will be a long project, so this will go on testing, iterating, connecting with the mentors, and different things will be done. My estimate is that a basic working POC might be ready by the DevCon, but even if the project extends by few months more, I will be happy to contribute to it. So yeah, this was from my side. Thank you.
Thank you very much, Aditya. Any comments, questions? Yeah, thank you very much. It's a great project.
Thank you.
Oh, we have a question from Dan. There are trade-offs for implementing statelessness on EL, e.g. while building the witness be permissioned.
Mostly the trade-off is with the latency only. There will be no permission or things like that. Every client has the feature. You can think of it as a flag. For example, if you are while starting your client, if you just pass a flag, like for example dash dash stateless, there will be stateless mode will be enabled and all the block. And along with producing a payload, a simple witness will also be added to the payload. and everything will go same. But instead of just relying on the local state, the client will be able to process the block uh, upon the witness also. So there is nothing like permission or something like that. Everyone can produce the witness.
Yeah, awesome. Thanks a lot, man. Yeah,
Thank you.
awesome. Next we have Oppenheimer and the crew, I guess.
Yeah. Let me just share the screen.
Great. Yeah, go ahead.
Cool. So hi guys, I'm Oppenheimer, and we are working on this project called Rated List DHT. Let me give you some brief, background based on which we have come to a conclusion that this is a valid project to work on. So let me give you a brief introduction into what DAS is. So data availability sampling is basically a scheme where a node in the network can probabilistically identify if the data is completely available in the network without even downloading like the entire blob data. So basically, column data can be sampled randomly. Right now, it's being sampled from subnet gossip and uh, am I audible? I hope I'm audible, right?
Yes, all good.
Yeah. The samples are basically taken from subnet gossip and randomly sampling from other nodes, based on which, on a race construction, the node identifies if the entire data is fully available. Right. So now, why is DAS in coming into the picture? Is because it's one of the parts that needs to be included as part of full tank sharding. So full tank sharding is basically trying to integrate the entire, fully integrate the data sampling into Ethereum sharding design, which eventually will lead to independently verifying if the data is available while maintaining the overall security and efficiency of the network. So now, where does the DHT come into picture in this thing? So right now, uh, the current implementation of the DHT that is being used in the client softwares is pretty archaic and uh, was simply not built for a large scale implementation such as Ethereum. So Kademlia DHT, which is currently being used, was basically uh, from starting from 1 to 2 nodes to about 100 node thing. But right now, if we see, Ethereum has a lot more nodes than that. So basically, it has no Sybil resistance, and that there are basically problems like key space flooding and things like that. So we basically attempt to try to solve those problems in our solution in rated list DHT. So yeah, I think Chirag?
Yes. So, regarding the project description, so what Dankrad had proposed was constructing a list of all the peers in the network, and rating them based on how you know them, basically. So it's a friends to friends model where you take your current peers, you add them to level one, and then you take their peers and you construct a routing table like that of the entire network. So that's the catch about the rated list DST, is that you have a routing table that maps the entire network. I'll get into the technical details of it later, but supporting research shows that creating a social network as such has a greater Sybil resistance, and the best benefit it has is that sample dispersal gets easy. There is not one routing table that that acts as a bottleneck for seeding the entire DHT, which is the case with Kademlia, which is used in this V5.
So what we will be doing is that we will be first, Ashley will be drawing out a formal specification which serves as an extension of the DAT specification written down by, I forgot, Michael Simkin, is it? But yeah, it's there in the proposal. Secondly, we'll build a POC, and the most important part would be to simulate and draw out analyses for the security and the network parameters. Next slide. As I told you, I'll get into the technical details. Is that when when the rated list or the routing table of one node is filled with all the nodes, the most immediate doubt we get is that how is it possible? Like, how is it possible to have a routing node of the entire network uh, in one node stable? This is actually the biggest myth about Kademlia, is that this, like Kademlia in general, they call it an archaic technology because it was released for resource constrained uh, machines, because that time we did not have like beefy machines like now. Right now in Ethereum there are probably about like 20,000 to 20,000 nodes on the EL layer, and there are 500,000 on the CL, and a routing table for them is a piece of cake for current day machines. So it's not a very big chunk of your RAM that it will take for maintaining the routing table, but it will add a significant amount of security to the sample dispersal. Um, However, right now, as I said, we all we have is the blog written by Dankrat. There is no formal specification, so Ashley will be helping us with that. But we know a few things about the rated list itself. Is that it would sit over existing peer discovery protocols like this V5. It might seem unintuitive that I just like lashed out on Kademlia and I'm saying that I'm going to use this V5 now. But there is a significant difference between using something for discovery, for bootstrapping, than using it as an overlay network for sample dispersal. So the layer is what matters. So yeah, so the rated list would come over this V5. We also know that we would be using deterministic selection as sample dispersal. So any query requires only one hop in the network. And additionally, we also know that the proposed DST would maintain a liveness index on a per slot basis. So it would calculate all the network parameters of the peer scores for the entire table on a per slot basis. Next slide. This is so our roadmap is, as we said, we have to work on the formal definitions first so that we have a clear view of what we are going to implement. Then we'll implement and then we'll verify, which is like a very rough plan and is the most sane plan that we have right now. But things might change as we go and find new things on the way. Thank you. Any questions?
Very well. Thank you, guys. Okay. Any questions? Comments? Yeah, I think it's great uh, that you help. Yeah, we had a presentation from Dankrat in the EPF day where he explained the proposal. So I'm very happy to see that somebody actually started working on it. Yeah. Okay. We have George here.
Hi, Mario, can you hear me?
Yeah, all good.
Oh, okay, so let me share my screen.
Awesome.
Let me know if you can see my screen.
Yeah.
Yeah, okay. Yeah, so I'm going to focus on the MaxEB, which is talking by the EIP 7251. The TLDR for my project is to focus on this ELPR, focus on this EIP, because EIP 7251 they try to managing the MaxEB, which the current implementation of this has been some problem. I will briefly introduce later. And also more importantly is this EIP has already been scoped into Electra upgrade, which should come mentioned by Tim in 2025 Q1 or around that time. The benefit of this EIP is they has the mission to control the validated size, and that will contribute to the SSF and also the EPBS. So currently it has 4 features. Is already working in progress. Given the urgent timeline, there are still 2 features remaining to start. So in this program, I will focus on to working on the remaining feature, which is on the customer sailing, set up the customer sailing for the Swift,